Okay, so today we'll be discussing about a result that tries to that basically gives you a condition about interconnection of um, two finite gain LP stable systems. This is an interesting result and is known as the small gain theorem. Okay, so let's say that you have a system represented by H1 whose input is E1 and the output is y1, and this is a finite gain LP stable system, which means y1 tau LP is less than equal to some gamma 1s times e1 tau LP plus beta 1, and suppose there is another system, let's say H2, whose input is E2, and let's say the output is y2. Now, and this H2 is also a finite gain LP stable system, which essentially means that this inequality with respect to E2 and Y2 would be satisfied. Okay, suppose this is what it is. Now if we interconnect this system, so let's say we have input y1 now, and this goes in like this. So this is input y2. Suppose we have this interconnection, so this minus that you see here can be either minus or plus, doesn't matter for this particular result. Now suppose you have an interconnection of this form, then when will this interconnection be finite gain LP stable? That is what the question is. Okay, so I'll state it properly. So suppose, okay, this interconnection that you see here is also known as the feedback interconnection. Okay, this is a feedback interconnection between two finite gain LP stable systems. Okay, so suppose H1 and H2 are finite gain LP stable, which essentially means that there exists a pair gamma 1 beta 1 and a pair gamma 2 beta 2, such that the LP norm of y1 tau is less than equal to gamma 1 times LP norm of e1 tau plus beta 1, and LP norm of y2 tau is less than equal to gamma 2 times LP norm of e2 tau plus beta 2. Okay, so suppose this is true. Now the question is, when will this feedback interconnection be finite gain LP stable? So the answer to this is, now suppose gamma 1 and gamma 2 is less than 1, then the feedback interconnection of H1 and H2 will be finite gain LP stable. So the product of the two gains, gamma 1 and gamma 2, that are involved in the inequalities are such that it is less than 1, then it is guaranteed that the feedback interconnection of these two systems will be finite gain LP stable. However, if this condition is violated, that gamma and gamma 2 is the product of gamma 1 and gamma 2 is less than 1, then we cannot guarantee about the finite gain LP stability. But if the product is less than 1, then it can for sure be guaranteed. Okay, now I mean, what does this essentially mean? Okay, so to easily understand why gamma 1 gamma 2 being less than 1 means that the system is finite gain LP stable. To see that, suppose the inputs u1 and u2 are 0. Okay, so if the inputs u1 and u2 are 0, then essentially you have this particular system in hand. So this is just a loop. E1 y1 h2, you have e2 y2. Okay, so when u1 and u2, let's say for the ease of understanding, you set u1 and u2 to be 0. Now what happens here is, let's say that for some initial condition you have some e1. Okay, you start from e1, you get a y1. Okay, and then from y1 is nothing but e2, and as e2 passes you get y2, and then you get e1. So what is happening is y1 is getting an amplification of gamma 1 on e1. Okay, so the amplification on y1 would be less than equal to approximately gamma 1 with respect to e1. Okay, now this y1 acts as input to h2, and it gives you y2. So y2 is going to be having a amplification less than gamma 2 as far as e2 is concerned. This is coming from the inequality itself. Okay, so the net amplification from e1 to y2 is going to be what? Gamma 1 multiplied by gamma 2. Now if gamma 1 multiplied by gamma 2 is going to be less than 1, then what you see is when you started from e1, the y2 that you get is going to have attenuation kind of thing. So what it is being guaranteed is it is not going to increase. So what is happening when you complete the loop, since y2 is going to be e1 or minus e1 depending on the choice of negative or positive sign there, what you see here is the magnitude of e1 will not grow. Okay, in fact for gamma 1 gamma 2 less than 1, this will decay, right? So this is saying that if we start from e1, travel the loop and end at e1, the net maximum amplitude that you are going to get is gamma 1 gamma 2, and this gamma 1 gamma 2 is less than 1, which means as progresses e1 will never grow. Okay, so that is why this gamma 1 gamma 2 less than 1 kind of ensures that the system is finite gain LP stable. Okay, uh, what I suggest you is the proof of this is nicely represented in the book by Nonlinear Systems by Khalil. I request you to please go through that proof. It's a nice small short proof which utilizes the inequalities that are given for finite gain LP stable and the inequalities involved with in general the norms to establish that the system is finite gain LP stable. So I suggest that you go through that once and see if you can make out anything on the proof. Okay, it's a easy proof, so I suggest that you go through this. So we end our lecture here on input output stability. From the next lecture onwards we will discuss about something known as passivity, which is basically concerned with passive systems. We'll see what passive systems are, what is the definition of passivity, and from there on we'll proceed further. So we will stop here. Thank you.